Okay, Mr. Harridan here. We're going to go over the components of an atom here. Okay? So there are three basic components of an atom. There are protons, there are electrons, and there are neutrons. Okay? Protons are positively charged particles. They are found in the nucleus. They are more massive than an electron, and the symbol we use for them is P positive. So these have a P positive, and the mass is considered to be 1 AMU, atomic mass unit. Okay? Found in the nucleus. Okay. Electrons. Electrons are very small, negatively charged particles. Okay? They are outside the nucleus. Okay? The mass is considered to be 0 AMUs. Okay, you're like, what? How can it be a mass of 0 AMUs? Okay, so here's the deal here. When we are comparing it to the proton, it takes 1,837 electrons to equal the mass of one proton. This mass is insignificant compared to the mass of a proton, so that they say that this has 0 mass, is the deal there. Okay? So basically, it's like when you get like $50,000 and you add a penny on it, nobody cares really. You're a little bit richer, but it's insignificant compared to the $50,000. That kind of thing, right? Correct. Of course. And the symbol for an electron is E minus. Okay? Neutrons. They are particles that are found in the nucleus. Okay? They have the same mass as a proton, and they have no charge. Okay? It is neutral. It is shown as N0. Okay? The mass of a neutron is considered to be 1 AMU. It's pretty close to a proton. And the symbol they use for it is N0. Okay? Atoms take up mostly empty space. Remember, Rutherford said that the atom is mostly empty space, and then there is a dense nucleus in the middle. Okay? Okay. Atoms, this is important here too as well, are always neutral particles. They contain the same number of protons as electrons. The neutrons do not matter in determining if it's an atom or not. So atoms have the number of protons. Why did I put P0? P plus, Mr. Harridan, equals the number of, I can't write of either, electrons. Okay? That is for an atom. Okay? The atomic number is the number of protons found in the nucleus of an atom. On the periodic table here, in the back, they got numbers in blue. On this one, there are numbers here. Notice that the periodic table is arranged by atomic number 1, 2, 3, 4, 5, 6, 7, 8. Each element has a unique atomic number that identifies the element. Okay? Atomic numbers are unique. Just like me. Right? Right. See, I got horns. moving on. The next term is the mass number. This is the number of protons and neutrons. Okay? Very important fact here about mass number. It is not on periodic table. You have to have a special periodic table to have one with the mass numbers. They're very hard to find. You do not have one. I do somewhere. Okay? But this is not on the periodic table. Okay? This is the sum of protons and neutrons. Okay? What is actually on the periodic table is the average atomic mass, which we'll go over on the next page. Okay? So this is a formula you're going to have to know. Protons plus neutrons equals the mass number. Okay? There are two different ways to write a mass number. Okay? If I'm doing, you're going to see boron 10 like this. That's the mass number. Or you will see me write boron hyphen, this is a hyphen, 10. Okay? That is the mass number. Okay? So if you see a number written after the name, that's the mass number. Okay? This is not a negative sign. It's a hyphen. Okay. How many neutrons are in uranium-235? Well, you see this 235 right here? That is the mass number. Okay? I know that mass number equals the number of protons plus the number of neutrons. Okay? So I know that this is 235. How do I figure out the number of protons? I use my handy dandy periodic table because I know it's uranium. And I know the symbol for uranium is U. So the number of protons is 92 plus N. So I do 235 minus 92. I believe that's 143. I'm double checking though. So N is equal to 143. That is how many neutrons are in uranium-235. Okay, you guys are champions. The legend is